Betul. Okey. Boleh tak masuk website sana? Test awak dia boleh dengar tak? Saya cakap. Betul, boleh dengar saya tak?
Boleh Doktor? Dengar?
Better macam ni ke atau tadi? Ni saya guna mikrofon Yang ni
Yang
ke
ni
tak?
macam bergema sikit.
Tak pakai mikrofon ke tak pakai mikrofon? Ni tak pakai mikrofon tau.
Okey, yang ni tak okey. Kalau Doktor pakai, try.
Okey, ni saya guna mikrofon.
Rasa better yang tak pakai Doktor sebab yang tadi Doktor cakap lagi jelas.
So maksudnya yang saya cakap ni jelas kan? Ni tak ada mikrofon.
Yang ni jelas. Yang ni jelas.
Siapa dia dekat dengan laptop. Dekat luar.
Nampak. Kamera kecil lah, clear lah nampak. So clear ni clear Clear tu? Ni clear, saya cakap clear.
Clear?
Okay,
Okay.
thank you. Tak apalah, nak keluar dulu pun tak apa, nanti masuk lagi. Right.
Okay, Doktor.
Click lah. Click lah.冇啦，一时叫下顶人家光伊搭无收着。伊敲电话给我，伊想到我都出来嘛。嗯。
Mic test. Mic test. Mic check 1, 2, 3. Hello, mic check. Hello, mic check 1, 2, 3. Mic check. Hello, mic check 1, 2, 3. Mic check 1, 2, 3.
Nak. Tidak on mikrofon dia kita dengar.
So nanti buka mic yang satu ni and then buka yang mic satu ni kan? Oh, yang ni tak payah. Hello, mic check 1, 2, 3. Mic check 1, 2, 3. Dapat dengar kah? Hello,
Boleh dengar?
jelas kah?
Jelas. Daripada yang semalam tu, yang ni jelas.
Hello. Hello. Hello.
Dengar tapi macam bergema sikit.
Dengar tapi macam bergema sikit. Agak sini.
Tak, Doktor. Nampak mic Doktor on tapi tak dengar.
Doktor boleh dengar saya tak?
Sekarang boleh dengar.
Oh, tadi tak dengar?
Tadi tak dengar. Tapi
Okey,
nampaklah
saya
mic
tutup
Doktor tu on.
mikrofon sekejap
Okey.
Sekarang dengar?
Dengar?
Tadi tak dengar?
Tadi dengar? Yang awal-awal tadi, yang masa Doktor
Oh,
mention
yang
dalam group
awal.
tu.
Oh, sebab saya tutup mikrofon tak dengar. Kejap
Tapi
saya
nampak label hijau ni kan maksudnya mic Dr. on tadi tapi tak, suara doktor tak dengar.
okey, sekarang boleh dengar lah. Maksudnya kena
Sekarang
buka
boleh
mic
dengar?
lah.
Sekarang okey?
Okey. Okey, tak ada bergema
Tak ada.
Clear
Clear?
Okey. Jadi so kalau cakap dari sini tak apalah, sana buka kan. Boleh alright. Sebab tadi dia tak boleh buka 2 laptop. Kena buka 1 je.
Oh.
Okey, tak apa. So nanti Vanessa cakap kat sini. Thank you Dato'. Hi, Toshi. Can you hear me?
Yes, yes, I can hear you.
Can you hear me clearly?
Yeah, no problem.
All right. How are you today?
Good, thank you.
Okay. So we will start at 3. The housekeeping will start around 2:50 to 55. So after that, some speech from our dean, and the MC will call you to for a presentation.
Okay.
Okay. So
About
good to
how
see
many
you.
about how many people will join?
Because we have two platforms. One is WebEx and one is YouTube Live.
Okay.
So I'm not sure, but we will have some participants in WebEx for you to ask them to do something. I think you want them to do activity, right?
No, just idea.
Okay.
Just I want to ask the idea. So
Oh, the ideas. Okay.
Yeah.
So
just writing down the chat box. Yeah. Okay. Anyway, I will wait.
okay. So I'll see you in a bit, yeah?
Yeah, thank you.
Okay.
Welcome and good day to everyone. My name is Vanessa Indah Anak Peter and I will be your MC for today's STEM webinar. Firstly, we would like to express our highest appreciation and gratitude to all for being able to attend this webinar event on sharing STEM skills from Japanese insights and perspectives. Before we begin, we would like to inform everyone regarding some housekeeping rules for today's event. Make sure that you are settled comfortably and is ready for the webinar event. For WebEx participants, please make sure that your microphone is always muted throughout the whole event to avoid any disturbance. Please make sure that your cell phones are in silent mode or vibrate to avoid any disturbance throughout the event. The Q&A session will be held at the end of the sharing session. So feel free to raise your hand and switch on your microphone for questioning, or you can also write your questions in the chat box section in WebEx or YouTube, as the committee will help you to pass it to the speaker. Dearest guests and fellow participants, our event will start soon. For your information, the attendance link will be provided in the chat box for every 10 minutes. So please be alert and remember to fill in your information in the given link. Your cooperation is highly appreciated. Thank you. And for your information, we will start at 3 p.m. sharp. Our Honorable Dean from the School of Educational Studies, Associate Professor Dr. Rahimi Chiaman, Our esteemed invited speaker, Professor Toshinobu Hatanaka from Toho University Japan, my STEM Ambassador USM Club Advisor and also moderator for this webinar, Dr. Nur Jahan Ahmad, my STEM Ambassador President, Ms. Nur Alia Shafiqah Ishak, Project Director, Ms. Hidayatul Amshar Bakar, and all project committee members, all teachers, educators, officers, students, ladies and gentlemen. First and foremost, we would like to warmly welcome everyone to the webinar event on sharing STEM skills from Japanese insights and perspectives hosted by School of Educational Studies USM and coordinated by My STEM Ambassador Club USM. We are going to play our national anthem, Negaraku, and the university's official song, Menara Ilmu. So please put your hands together.
University Sains Malaysia, menara ilmu tercinta, jadi tumpuan antara bangsa untuk segala cita-cita. Berinovasi, berteknologi, berwawasan, berkualiti. Biar usaha kami bersemi, hasratnya lah berseri. University Sains Malaysia, menara ilmu tercinta, jadi tumpuan antara bangsa untuk segala cita-cita.
Also, to bless the event, we would like to invite our lecturer, Dr. Muhammad Norawi Ali, to recite the prayers. Please welcome, Doctor.
Bismillahirrahmanirrahim. Alhamdulillahi Rabbil Alamin. Wassalatu wassalamu ala ashrafil anbiya wal mursalin wa ala alihi wa sahbihi ajma'in. Allahumma salli ala Sayyidina Muhammadin wa ala ali Sayyidina Muhammad. Allahumma ya Allah, ya Rahman, ya Rahim, ya Hayyu, ya Qayyum, berkatilah perjumpaan majelis ilmu pada petang ini, ya Allah. Oh Allah, we seek refuge, your blessing, so that this webinar on sharing STEM skills from Japanese insights and perspective runs smoothly from beginning to the end. Strengthen our collaboration, networking, and solidarity in promoting awareness, knowledge, and STEM best practice, making our Mother Earth sustainable and harmonious for living. Oh Allah, you are all the hearing and all the knowing. Increase useful knowledge and understanding, and guide us in disseminating and doing best and practicing in our daily life. Make the farewell of this event full of blessing and forgiveness from you. O Allah, you are the most gracious, the most merciful. All praise belongs to Allah, Lord of the worlds. Most gracious, the most merciful, Master of the Day of Judgment. You alone we do worship, and you alone we do ask for help. Guide us to the right path of those upon whom you have bestowed favors, not the path of those who have evoked your anger, nor of those who go astray. ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار. وصلى الله على سيدنا محمد وعلى آله وصحبه أجمعين. سبحان ربك رب العزة عما يصفون وسلام على المرسلين الحمد لله رب العالمين.
Thank you, Dr. Norawi. Ladies and gentlemen, now we would like to invite the Dean from School of Educational Studies, Associate Professor Dr. Rahimiche Aman, to give her welcoming remarks. Professor, the screen is yours.
Thank you, Miss MC. Okay, check sound, it's okay. Honorable guest speaker, Professor Toshinobu Hatanaka from Toho University, Japan. My STEM Ambassador Club Advisor, which is Dr. Nurjahan Ahmad. MPT, my STEM Ambassador Club and members, fellow educators, teachers, officers, and my beloved students. Assalamualaikum and very good afternoon. It's my pleasure to say a few words before the sharing session with Prof. Hatanaka. When we talk about STEM education in Malaysia, STEM components are integrated mostly in science, mathematics, and technology subjects. But it's quite trendy now, where the STEM components are also cut across many subjects, even in language and religion. Having STEM skills are needed as our country is still short of workers in STEM field. That is why we need to recruit international experts to fill the vacant posts. The Ministry of Education Malaysia has emphasized the importance of STEM education in Malaysia Education Blueprint since 2013. According to the blueprint, the factors underlying the declining enrollment and quality of student outcomes in STEM fields are due to the limited awareness about STEM, perceived difficulties in STEM subjects, or it's about perceived. It's not really the matter subject. The contents curriculum is heavy, inconsistent quality in teaching and learning, limited and outdated infrastructure. As Malaysia is becoming a developed nation, to meet the challenges and demand of a STEM-driven economy, thus our government has prepared many initiatives to overcome the shortage of workers in the STEM field. Besides training our teachers and educators to be competent in STEM skills, among the initiatives done by the government are the new enhanced curriculum in the primary and also in the secondary level prepared by Curriculum Development Division, where they emphasize higher order thinking skill, which is we call HOTS, such as analyzing, critical thinking, hypothesizing, and decision making. Encourage project-based and inquiry-based learning. For example, laboratory work, student-directed inquiry, and ICT game-based instructional materials. and also address performance in international assessment such as TIMSS and PISA. Malaysian of Education Malaysia will continue to collaborate with institutions such as museum and science center to develop or scale up learning program for students. This program may be built into the curriculum or delivered after school as an enrichment activities. The ministry will run a campaign to educate the public about the diversity of career opportunities in STEM-related fields so as to encourage more students to select STEM subjects. So this webinar is also one of the good example for enhancing our competency in STEM skill outside the classroom. Thank you so much to Dr. Nur Jehan for her effort and team in order to organize this webinar with the collaboration Toho Universities. My final say is we hope to produce more qualified STEM graduates to fulfill the employment needs in this field to fuel our Malaysian economy. And we hope that this webinar, we can learn from Japan about the insight and perspective in the STEM skills, as Japan is very well known in their advancements in science and technology. Thank you so much, Prof, for your kindness to have a session, good sharing session with us, with all us in today's session, with the students and all the educators for this webinar. Thank you so much. Assalamualaikum warahmatullahi wabarakatuh. Hopefully you enjoy this webinar.
Thank you so much for the great and wonderful welcoming remarks, Professor. Ladies and gentlemen, before we proceed to our sharing session, we would like to introduce to you our invited speaker who will be sharing about Japanese insights and perspectives about STEM skills. Professor Toshinobu Hatanaka is a professor at the Faculty of Science, Toho University Japan. He holds a Bachelor of Science in Physics, Master of Education and a PhD in Education from University of Tsukuba. He has been teaching science education for prospective teachers at the university for 18 years, and after working as an international volunteer teacher for 2 years in a Pacific country, and as a secondary school science teacher for 4 years in Japan, he spent 1 year from 2016 as a visiting scholar at University of Arkansas, USA. In addition, he has experience in training teachers from Southeast Asia and Africa, and in recent years, he also served as an online teacher trainer at the Southeast Asian Ministers of Education Organization Regional Center for Education in Science and Mathematics, Malaysia, and Institute for Research and Development in Teaching Profession for Asian, Thailand. He is an experienced researcher and involved heavily in research related to science education and science teacher education. He is also the editor, writer, and reviewer, and has published many articles and books in science education and science teacher education. Ladies and gentlemen, put your hands together and please welcome Professor Hatanaka on the screen, and the question and answer session after will be handled by Dr. Nur Jehan Ahmad. Professor, the screen is yours.
Thank you very much for warm interaction. Dean of School Education, Dr. Rahimi Chairman. And thank you very much for preparing this session, Dr. Nur Jehan. Assalamu alaikum. Good afternoon, everyone. I'm really pleased to share my knowledge with you today. I think more than 100 people are attending this seminar, so I'm really happy to share my knowledge. And in the Q&A session, it's good if you can give me some comments comparing your education system. If you can share that idea, maybe I can learn from you also. Anyway, I will share my screen. I think this one. So today I will share this topic, sharing STEM skills from Japanese insights and perspective. Can you see my screen? I share my screen, but my slide cannot come out in the YouTube channel.
Yes, can, Professor. We can see it clearly.
Oh, really? Okay. Okay. So my name is Toshinobu Hatanaka. I'm a professor of science education at Toho University Japan. So I think you might not know well about Japanese education system. So before I start my talk, I just want to share a little bit about Japanese education in general. This is the school system. Elementary school, we have 6 years. After that, we have junior high school 3 years, 3 years in the senior high school. Then they study in university. This is the basic school system. And if you go to this website, you can learn something about Japanese education. This is one of the pamphlet paper in the website, and they explain about a day in elementary school. So sometime they focusing this activity. We have a lunch time. They can share, they can eat lunch, and they can learn about the nutrition and the manners. That is somehow different from other countries, I think. The another thing is clean up. Student clean their rooms every day. So that is part of our education program. It might be different from other countries. And today I'm going to explain about the science education in Japan. I want to share one result of international assessment test. It's a PISA 2018 result. In science, we ranked relatively higher position. I don't know it's because of our Japanese science education in school, or maybe the student also can learn from outside school. But anyway, our achievement test is relatively higher. So I hope you can find something good from my presentation today. So today, I'm going to talk as much as concrete. I want to explain the science topic in grade 6, combustion. In grade 6, the age of the student are from 11 years to 12 years. And it's the last year of the elementary school. So I'm not so sure some of you are not good in science topic, but the topic is an elementary one. So the scientific concept is relatively easy. So maybe it's easy for you to understand. So in elementary school, grade 6, they study about the combustion. And normally, they spend 9 lessons in this topic. I checked the textbook company plan. And in Japan, we have a national curriculum, and textbook company make a textbook following the national curriculum. So almost all the textbook have very similar. And I believe that's the normal. even though they're using another company's textbook, but they usually spend 9 lessons or 8 lessons or something like that. And 45 minutes for one lessons. And in grade 6, they learn 3 lessons a week. So to learn this topic, they usually spend 3 weeks. So the basic character, I will explain about the characteristic of science in elementary school. They only teach basic scientific concept. In this topic, the concept is just something like this. When the things burn, oxygen is used and carbon dioxide is made. And the air is composed of nitrogen, oxygen, and carbon dioxide. That is almost all the scientific concept in this topic. So it means they spend 9 lessons to learn these scientific concepts. What do you think? They spend lots of time, right? And the lessons are problem-solving approach. And they learn STEM skills in the science lessons. I say STEM skills because there is no term STEM in our national curriculum. And it's a little bit difficult for us to, if I met some teachers, do you know STEM skills? They might say they don't know anything STEM. We don't use STEM much in Japan, but I know about STEM, and I believe that they don't know about STEM skills, but they already taught some kind of STEM skills in their class. So I just put the STEM skills here. And in this seminar, I will explain about what kind of STEM skills they can learn in the lessons. And in today's talk, I'm going to explain STEM skills based on my research with an elementary teacher. So I implemented some of the teaching materials with him. And I checked the science textbook. So I checked the flow of the lessons in the topic. And I'm going to use the educational television program. So in my seminar, you will see students' face because they took a science lesson video and showing in the educational television program. Later, you can check this URL. You will see the whole video. So let's talk about STEM skills. STEM is consists of science, technology, engineering, mathematics, right? Those are the process. Scientific inquiry start from question, design investigations, and they conduct experiments, observation, and drawing conclusion. This cycle is scientific inquiry. And engineering design, I took a diagram from NGSS, American Curriculum. And they say that they define specified criteria, constraint that a possible solution to a simple problem must meet. So the engineering design process starts from the question, and they develop solutions, they optimize. So in the topic, they can apply those process. Let's start from engineering design. So engineering design is a develop solution to a problem. So when I conduct these STEM lessons with elementary teachers, I brought a problem like this. A teacher said, I forgot to bring a stove to camp. Because I want to make a fire with a stick, but I forgot to bring a stove like this. If I have stove like this, I can light a fire like this. But I forgot to bring. That is the problem. And the teacher told student, and teacher asked some other ideas from students. But next one, I can bring, I can find a can. So I decided to use a can. Yeah, I choose 2. And I open the can. I try to make a stove like that. I open the balls of the cans. Then I blow paper, chopsticks. I break a chopstick into 3. Put the paper inside the can. And put fire. You see that we cannot see a big frame, right? So it doesn't work well. So that is the problem. So materials are cans, paper, stick. Then I have to find out a way to make the fire bigger. So teacher can ask, what can we do? So I want to ask you idea. What you can do, how you can modify, or what is your idea to make a better stove? If you're using WebEx, please write down in the chat box. And if you're using YouTube, you still can use a chat box. I can see your chat box also. So please write down your idea. I will stop for a while. Use old newspaper. Add fire starter. Yes, it's good idea. If you have fire starter, that unfortunately I only prepare the cans and paper and stick. So what is your idea? Well, do you have any other ideas to make a better stove? Yeah, build hole at the bottom. Yes, that could be work. Any other ideas? Use cloth. Can be. But I only prepared can, paper, and stick. So leaves, yes. We can find another materials. Add more paper, can be. But what if we cannot change the amount of materials? Cans, paper, stick. Maybe we can adjust we can change the can, right? Okay, thank you for writing in, your idea in the chat box. I decided to make some holes. Yeah, I brought some equipment. That is the tool to make a hole. Usually we use those tools to make a hole for leather. I made 4 holes. So there are 4 holes. Then I can compare. I prepare same amount of paper and stick. Cut into 3. Put paper. Yeah, another sheet of paper in the can. So the left one have 4 holes. The right one have 1 no hole. You see, the left one makes a bigger frame. So I can measure the height of flame. Of course, you can check other things, maybe the temperature or maybe the time. So I tried this 3 times. The first trial, 8 centimeter high. Second one, 12, or third one, 5 centimeter. But this one, no hole, no frame. So from this activity, we can say the can with 4 holes works better. But that is just one idea. So we can try another idea, right? Any other idea? Please write down your idea in the chat box, please. I will open the chat box. Where is chat box? Yes. Try in a closed space and try with the windows open. What did it mean? Closed space. It means put in a box or something. Oh, windows. It means make a windows in a can. Indoors and outdoors. Okay. You can change. Any other ideas? Please write down. Blow the can. Add fan nearby. Yeah. Can be. Any other ideas to make a better one? The can with 4 holes works well, but we want to have a better one, right? If you have other ideas, add glue stick as fuel. More holes. Yeah, I want to put more holes. Yes. A small hole near bottom of can. Yes, more stick. Yeah, but if we change the stick, we don't know which one is better. We only can change the one condition, right? So let's stick to use same materials like can, only can, paper, and stick, same amount. Maybe we can arrange the can. Break the stick up into smaller bits. Yes, that's another idea. So thank you very much for liking your idea. Use close, yeah. So yeah, maybe we can make 8 holes, or maybe we can make holes at the bottom, or maybe the top, or maybe we can change the can, bigger one or something. Then find out the solution. That's the engineering design process, right? One of the example of engineering design process. So in my research, I and my co-teacher decided to make this activity at the beginning of the topic, or let them familiarize the phenomena and let them enjoy this activity. So that this activity is related to engineering design process. Okay, so let's move to the next process, next one, science, because it's a science class. So scientific inquiry is a bit different from engineering design. The engineering design process, they have to do, the engineering design is for develop solution, right? But in scientific inquiry, the process is to find out explanation based on the evidence. So maybe after that activity, the teacher can say, why did the can with 4 holes work? Teacher can ask like that. And air is needed. Student can say like that, right? So we can check design the investigation and conducting experiment. So if you say the air is needed, what do you want to find? Teacher can ask like that to students. Maybe one of the question is that what will happen if the amount of air is different? They can prepare some kind of experiment related to this question. I brought the two container, same size. I put candles. And close the container. The fire went out at the same time, right? Because the same size. So from this experiment, and also teacher can blow the two different sized container, bigger one and smaller one. Of course, bigger one has a more air, right? And then we can close the container with a lid. And the bigger one lasts longer. So the question is, why did the can with 4 holes work? If students say air is needed, then we can prepare, or student can think about the experiment like this, comparing two containers, same size, different size. And the question is, what will happen if the amount of air is different? If we put a lighted candle in the bigger container, the fire stays longer. So from this experiment, they know the fire needs air. They can find out the reason, explanation. The fire needs air. If there are more air, the fire stays longer. So using this cycle, they can finding out the explanations. In another, let's go to the next cycle. There are a lot of cycles in this topic. What will happen if we open a container when we put a lighted candle? In the last experiment, we shut the container with a lid. What will happen if we open? We can design the experiment like that. We can open the container. We can stay open. You see the fire is smaller, but still lighted. So if we make a space, the fire can stay, cannot go out. The other experiment is that we can prepare clay. So teacher can ask student what will happen if we use this kind of clay and the container like that. There is no bottom. So we still can put same candle and we can compare. So both of the fire went out because we closed. Another design of the experiment is still we float clay. Maybe. I'm sorry, I think that's the same video. If I stay opened, of course, the fire stayed. The fire didn't go out. This is the same setting, but we can design the experiment like that. We can cut the clay at the bottom. Then we can put candles into the two containers. I think, what do you think if we compare the size of the flame? Maybe the light side one is bigger, right? There is a space at the top and the bottom. There is a space only at the top on the left one. The fire on the right side one is bigger. So the student can observe the differences To observe more, we can blow some incense. We can see the movement of the smoke. The smoke go into the jar. So it means the smoke go into the container from the bottom and go up like this. So the scientific concept is that the fire needs fresh air. That is the very basic idea, but the student can conduct these kind of experiment. They can try several trial, different setting, and they can check it. Same size container, different size container, the container open one, or the container which didn't have a bottom, and make a space at the bottom and observe, compare the two candles, something like that. So what will happen if we open a container when we put a light candle? So we do this kind of experiment, and the conclusion is the fire needs fresh air. They still don't learn anything about oxygen, but before learning about oxygen, they conduct several experiments. So let's move to the next one. The student already find out fresh air is needed. But another question is, does the air change in the container? Some student might have such kind of question. Teacher can ask why, or what do you think, or what is your idea? The student can say something like that. So that time, teacher can demonstrate some experiment like this. I will show some video from the TV. Students say air changed. We will find out the result from this experiment. We can shut the container with a lid. So the question is, the air inside the container is same as before or not? Oh, so when we open the lid and put onto the fire went out. So from that experiment, we can say the air has changed in the container. So student can check the components of air. And the air is consists of nitrogen, oxygen, and carbon dioxide, right? And the student can check the differences between nitrogen, oxygen, and carbon dioxide. This is a video clip. They can conduct the experiment like that. Put the nitrogen, oxygen, carbon dioxide, and put the candle. the fire went out in the nitrogen and carbon dioxide. But in the oxygen, the fire getting bigger and brighter. The candle can burn only in oxygen. And also they can check the components of air using equipment like this. In the textbook, they showing these equipments. This is the tool to check the amount of air, nitrogen and oxygen, carbon dioxide. We can use these tools in the science class. We put a small tube. There is a chemical inside the tube. Before we put the candle, we check the amount of oxygen. This is oxygen. This is carbon dioxide. The oxygen is 21%, and carbon dioxide is 0.01%. After we put the candle and the fire went out, we check the amount of oxygen is 17%. And the carbon dioxide, 4%. So if students want to finding out how the air changed, they can use those tools to find out amount of our oxygen and amount of carbon dioxide. They can check by themselves. The problem is that why did the fire go out? They didn't know that the air has changed. The amount of oxygen has changed and the amount of carbon dioxide increased. They have learned about that, but they don't know why. How they can, what kind of investigation or experiment they can think about. What is your idea? What is your plan to check, to finding out the reason for that question? We already know that fresh air needed, but we want to know more about the phenomena, right? Why did the fire go out? In the last slide, we already know the air has changed. But we want to know why. We want to design an experiment to find out more about this phenomena. So please write down the chat box. What could be the reason? What is your idea? Why did the fire go out? So I will open the chat box. Oh, I have another question, sir. So I have a question. How is the specific gas inserted into the gears? Wait. I want to clarify these questions. Kasvini, Miniandi. How is the specific gas inserted into the jars? Is your question is related to these tools? Wait. Is your question related to this equipment? Oh yeah. We bring this handle. When we bring this handle, air can go inside from the other end. Let's play. We put the tube. The air can go inside from this end. No, it's not in the underwater. That is just it's just a container. Before we put the candle, we will see the amount of oxygen and carbon dioxide. After we put the fire, you see, we bring the handle, then the air go inside from this end to this tube. And the air can touch this chemical, and the color of chemical is changed. That is the equipment. Oh, thank you for the question. Okay, so let's move to the question. Why did the fire go out? We already know that the amount of oxygen has changed and the amount of carbon dioxide is changed. So how do you explain? What is the idea? Please write down your idea in the chat box. We also can check. I also can check the chat box in the YouTube. Oxygen is burned to make carbon dioxide, but how to test it out? So we already know that before burning, 78% are nitrogen. Oxygen is 21%. But after we put the fire after burning, the amount of oxygen is only 17%. And before burning, the amount of carbon dioxide is 0.04. But after burning, the amount of our carbon dioxide is 4%. What has changed? What's the difference between the two? So, thank you. Yes. There might be two ideas, right? Thank you very much for writing the chat box. The one idea is that the oxygen decreased. The other one is carbon dioxide increased. Which affects? Do you know the reason? Do you know which affects? Oxygen or carbon dioxide? Decreased oxygen or increased carbon dioxide? Which one is the reason? The teacher can let the student discuss like that. Okay, so let's see the student discussion. So why did the fire go out? That is a question. Which student want to discover? And the question is, can you explain why? The student already know that the fresh air is needed. And we already know that air has changed. The question is that which one is the correct? There is less oxygen in the air after burning, or there is more carbon dioxide in the air after burning. Which affects? That is the problem that the student want to discover, right? So in the science class also, they come up those ideas. This is the video clip from the educational TV. Let's check it. She said all the oxygen is used up. The fire needs oxygen. That is what she said. That is her idea. So there is no oxygen after burning. Oxygen is needed for burning. That is those students' idea. So she said oxygen should be more than 17.1%. She said the important thing is that certain amount of oxygen is needed to burn. And she said that to burn more than 17.1% of oxygen is needed. That is her idea. So what kind of experiment are you going to prepare? So let's see the cycle. Why did the fire go out? Idea is there is not enough oxygen in the air after burning. So they decide the experiment like that. Put a lighted candle in nitrogen 83%, oxygen 70%, and carbon dioxide 0%. So they can check with this condition. So you know what will happen what will happen if we put the candle into that container? Let's see the result using a video clip. That is the plan of experiment. Nitrogen 83%, oxygen 70%, carbon dioxide 0%.
窒素 83%、酸素 17%、二酸化炭素 0% の気体に火を入れるという実験。
So we do this experiment. We put the oxygen 70%. We put the water. We put the container into the water and put the nitrogen now. 83%. Oxygen 70%, nitrogen 83%.
どうなるだろう。
So what will happen if we put the candle?
燃える前と比べると酸素は
So
17%
this is before the burning, this is the after burning.
酸素
So this is the condition of this experiment.
どうなるはず？
So what is your idea? What will happen to this
意外ね。
candle?
消えるのに二酸化炭素が増えたこと
The carbon dioxide doesn't increase, 0%. But only the oxygen decreased. That is the setting of the experiment.
実験結果は
In this experiment, the fire went out.
この実験結果からどんなことが言える？
So what can you explain from this experiment? That is the video clip. So what can you explain about from this experiment? Can you write in the chat box? When we put the candle in 83% of nitrogen and 17% of oxygen, the fire went out.
窒素83%。
Yeah, that is the things we can find out from this experiment. Why did the fire go out? Idea is there is too much. No. When we put this fire into this condition, the fire went out. The conclusion can be more than 17.1% of oxygen is needed to burn. We can get the result like this from this experiment. So 70% of oxygen is not enough to burn, right? That is what we get from this experiment. Let's move to the next setting. Another idea is like this.
酸化炭素だと言える。
His idea is the carbon dioxide is the one which killed the fire. He said the things which makes fire go out is produced.
燃えた後、増えた
I mean that first the carbon dioxide is 0.04%, but after the burn, after we put the candle, the amount of carbon dioxide increased into 4%. And from this idea, he said that carbon dioxide is the one made the fire go out. That is his idea. So from that idea, we can design the experiment like this.
酸化炭素だと言える。
The idea is there is too much carbon dioxide in the air after burning. So we can put a lighted candle in 75% nitrogen, 21% oxygen, and carbon dioxide 4%. So what do you think? What will happen to the candle if we put the candle into that container? What is the idea? Does it burn? Please think about the result and writing down your idea into the chat box, please. But the fire will go out after a while. Okay. Any other idea? I can wait 1 or 2 minutes. Please write down your idea into the chat box. Everyone agree? The candle can burn. Yes, okay. Thank you. Let's check. Okay, let's check the result. So that is the plan. We prepare 75% of nitrogen, 21% of oxygen, and 4% of carbon dioxide.
1%、二酸化炭素4%の気体に火を入れるという実験。まずは酸素を
Putting
21%
oxygen,
入れる。
21% of oxygen.
次に二酸化炭素を
And carbon dioxide, 4%.
残り 75% は窒素を入れる。
Nitrogen, 75%. That is the setting.
ここに火を入れるとどうなるだろう。
Oxygen, carbon dioxide, nitrogen, right?
酸素は
So the
20
amount of oxygen is same before burning and this education setting.
ことが関係しているとしたら火はどうなるはず？二酸化炭素は 4% で増えているね。火が消えるのに二酸化炭素が増えたことが関係しているとしたら
If
火は
the
どうなる
amount
は
of
ず？
carbon dioxide affects, what will happen to the fire? That is
実
another
験
question.
結果は
When we put the candle can burn
こ
for a
の
while.
実験結果からどんなことが言える？
So what can you explain from this experiment?
1%。
So this is the setting. We design investigations and we conduct experiment. And the candle doesn't go out with 4% of carbon dioxide. The candle can burn in this setting. That is another experiment. Yes, amount of carbon dioxide doesn't affect the fire. That can be the explanation, right? So the students have learned fresh air is needed, and they know that the air has changed. But there might be two reasons. There is less oxygen in the air after burning because the amount of oxygen is decreased from 21% to 17%. And there is more carbon dioxide in the air after burning because the amount of carbon dioxide is from 0.04% to 4%. But after we check the experiment, we find out there is less oxygen in the air after burning. We get this kind of conclusion that this idea is not correct. So why did the fire go out? We put a lighted candle in this setting and this setting, and the conclusion is a candle needs enough amount of oxygen. So there are lots of experiment in the combustion topic. And in the textbook, usually the schools spend 9 lessons to learn this concept, this simple concept. But they spend many kinds of experiments, right? This is the overview of science learning in the elementary school. Let's summarize the STEM skills. So in this topic, we can apply engineering design process. That one is the one design process to make a stove. And also, we can apply scientific inquiry process. We can prepare several kinds of experiments, and we can conduct scientific inquiry several times in this topic. Oh, I forgot to show you the stove. After you conduct the experiment of the electric stove, you can show them a stove, which I bought it in the shop. There is a hole at the bottom. Right? We can put the fire. In the stove, we have a hole. So the things we made in the engineering design, the design is somehow similar to this stove. Anyway, to learn about the combustion, we can apply two different kinds of process, engineering design and scientific inquiry. And when they learn this topic, maybe they can engage the activity, and usually they work in the group, so they cooperate each other. That is one of the outcome. And from this topic, they can learn general inquiry skills, thinking skills to solve problem. I mean that they have to find out the question, and they have to refine the question, and they have to find out a way to solve the problem. Especially in these lessons, they using scientific inquiry, so they have to design the experiment, and they have to conduct the experiment, and they get the reason from the experiment. 授業中なので。So sorry, my student came to my office. And also, they conduct experiments, so they practice scientific practice, and they got inquiry skills like manipulative skills. They have to manipulate the equipment. Also, they have to get a conclusion from the results. That is one of the thinking skills in this process, in the scientific inquiry process. And they conduct a lot of experiments, and they get the idea based on the evidence. In science, we get the idea based on the evidence. That is one of the characteristics of science. So sometimes teacher can say, what do you think to students, but the students have to explain based on their observation or based on their data. That's the way of thinking in science, right? So they can understand the concept based on the evidence. That can be the outcome of this experiment. And also, they practice the science, so maybe they might get positive attitude to science. Yes, if they practice those scientific inquiry, they might know better about what is science. In the science, you know, that they have to finding out the question and they have to solve the problem by conducting experiment and observation. But sometimes there might be some challenges. It's time consuming, you know, the concept is very simple. We only teach them about oxygen, carbon dioxide. And when the things burns, they use the oxygen and make carbon dioxide. That's the very simple scientific concept, but they spent 9 lessons. So it's time consuming, but our curriculum is make something like this. So it's okay for them to spend the time, and they expect getting skills from this learning, from this kind of learning. So they are not much concerning about scientific concept, or they are more putting emphasis on the STEM skills, like these general inquiry skills or scientific inquiry skills. And but if we put more experiment, more approach, sometimes it conflicts with the requirement curricular content. That is the regular one. I just finding out that those concept experiment from the scientific science textbook and from the video. So it's not too much, but some teachers want to spend more time for the activity, but it's sometimes it makes a conflict with the curriculum. And they have to think about a better way to get students be involved. So they have to give them a good question, or they have to facilitate their learning in the activity. That is also a big challenge for teachers. Those are some difficult part in this experiment, but we can teach using like that. Okay, so that's the grade 6 topic, combustion, how the students learn about combustion in the grade 6 in Japan. I still have some time, so maybe the teacher can give students some extra question like that. I want to show one more experiment. I want to stop here. I want to open the browser. Browser. This is the also same TV program. And this is another question related to combustion. Let's see it. That's the Japanese education TV program. It's somehow related to the activity, but it's more than that. So. This is a candle. We can light a candle. when we put the container,
火は
the fire went out.
消えてしまいます。では、ここからが問題です。
The question is that
2本のろう
we
そくを並べ
prepare two different lengths
火をつけ
of candle. We prepare two, but the length is different.
ここにこの瓶をかぶせると
And we want
一
to
体どちら
put
が先に消え
the
るでしょうか。
container.
長いろうそくが先に消える。
Which candle's fire went out first? Go out first? That is the
2本同時
question.
に消える。
Which
どうな
one
るか。ではやってみましょう。
go out first?
答えは番組の最後に発
So that is the question. We have two candles. One is longer one and the other one is smaller one. So which candle go out first? Which one lasts longer? That is the question related to this topic. Write down your idea in the chat box before we check the result. So do you get my idea? Taller one or shorter one? Maybe the shorter one. How about others? Can you write down your idea? Taller one or shorter one? So thank you, Kasubini, the cause air move up. So the taller one can have more air. How about others? Please write down your idea in the chat box if you have idea. Both fire go out at the same time. Thank you. Till short one go first. Both is same. Oh wait. So any other idea? Shorter one. Same time. Okay, so maybe let's check the result. Maybe the result is somewhere here. Together, both together.
先ほどの答えです。皆さんちゃんと考えましたか？ 1、長いろうそくが先に消える。2、短いろうそくが先に消える。
Longer one or shorter one
2本同時に
or at the same time? Which one go first? Longer one.
長い方が先に消えました。
That's the result.
短い方は
Then the shorter one.
今やっと消えました。なんで長い方が先に消えたのでしょうか？
So you
ポイ
can
ントは二酸
you
化炭
can
素。
write
二
down.
酸化炭素は普通、酸素より重いのですが、実はあた
So he said something related to carbon dioxide. But she didn't explain about the reason. Anyway, we still can do some activity like that, and we still can discuss something related to this topic. That's out of our curriculum, but we still can do some activity like that. Yeah, carbon dioxide is heavier than oxygen usually, but in that experiment, something different happened, I think. Okay, so maybe almost is the time. So we explain about the STEM topic, STEM skills in combustion. And the process is engineering design scientific inquiry. The student can get something like that. And I also explain about challenges. So thank you very much for attention, Telemakashi. Maybe now I can explain, I can answer some of your questions.
Okay, thank you so much, Prof. Hatanaka, for a very informative and enlightened us with the very good examples. So from your presentation, so we can see that there are two approaches that we science or maths teachers can use, either using engineering design process or scientific inquiry. All right, so before we open to the questions, so may I would like to know when is actually, when we want to use EDP or scientific inquiry, so is there any different criteria of the activity? When should we use EDP and when should we use scientific inquiry?
Usually in science class, engineering design process can use at the beginning of the topic or at the end of the topic. I think at the beginning of the topic, they can practice and they make something and they raise some questions. Then they want to find out the reason why it works like that. Like the one which I explained today, I prepare the engineering design process at the beginning of the lesson to get interest. But if we put the engineering design process at the end of the topic, maybe they can apply what they have learned in the topic. They have learned already about what affects, what kind of air, what kind of things is needed for make things burn. They can apply that concept and make some something applying engineering design process. So I can say, I think at the beginning or at the end in science class. That is my idea. Maybe different people have some different ideas, right?
Okay, thank you, Prof. So probably we can use EDP earlier to just identify the problem, and then we can investigate further using scientific inquiry, right?
Yeah.
Okay, thanks, Prof. Okay, we have one question from the participant. In your activity, how actually we incorporate or integrate mathematics?
Yeah, in this topic, it's a little bit difficult to incorporate mathematics. But in the other subject, in other topic, we can apply mathematics. Like when we study about level system, you know, we have to use the multiplication for calculate to make the things balance. Or maybe in junior high school, they have to they have to draw a graph or they have to calculate. There are a lot of topic related to mathematics. But unfortunately, I brought the topic which is not much related to mathematics today. Yeah,
Yeah, but what about the calculation of the percentage of gases or the volume, you know, based on the how much the air is being
But we use tools, right?
Yeah.
To check the amount of oxygen.
So it is also, I mean, like some mathematics there.
Mathematics, yeah. If we said let's
Yeah.
calculate the amount of nitrogen, yeah, we can calculate like that.
Yeah. So, I mean, we still can calculate the amount of
Yes.
oxygen, right? Is in the activity that you showed us?
Yeah.
Okay.
My video is off.
Yeah. Okay. Thank you, Prof. All right. So we still got time. So we open questions from the participants in WebEx. If you have any question, please raise your hand. And the participant in YouTube, you can write in the chat box. Yeah, we got some time for a question and answer. Actually, I'm very interested in engineering design process, Prof, because actually, all right. Okay, Prof, before that, we have a question here. How do we get ready for assessment in STEM? I'd like to say that STEM assessment goes beyond the standardized test.
I think so. Very deep. I don't have much idea about the STEM assessment. Yeah, maybe because we have to think about attitude or engagement, and that they are interested in the activity. So in the
Okay, what about in Japan? How is actually STEM integration of STEM? Is it like as a subject or integrated in science and mathematics subjects?
Our national curriculum started around 4 years ago in elementary school, and there is no any word STEM in our curriculum.
Okay.
So we don't much think about the STEM in our science teaching, and the teacher also. But as I explained like that, we still do similar STEM activity in the topic. We can conduct it. We already practice it. So I can say there are some STEM component in Japanese curriculum already.
Okay.
Oh, there is no any clear assessment for STEM in Japan. And I want to explain a little bit about elementary science assessment in Japan. We don't have standardized test. They just give them some paper test, I mean the quiz to students, and teacher observe how they perform the activity. And the teacher asks the student to write down a report, short report, or teacher can check the notebook of students. So in the elementary school, generally, teacher assess their learning in the various way, not only the paper test, but observation and how they, what is their talk, I mean that what they taught in the science classroom or something like that. So yeah. So we don't have standardized tests in elementary level. That
Okay.
is one of the different.
Yeah, in Malaysia also we are integrating STEM. We don't have STEM as a subject, but we call STEM subjects like maths, science, they are categorized as STEM subjects. Yeah. And what about the you know, do you have any problems with I mean workers, you know, in STEM areas in Japan? I mean, like, do you have any shortage, or you have enough STEM workers, you know, people probably in technical line or engineering or medical? So do you have any shortage, or do you have no problem with that?
No, I believe there is a shortage in the STEM workers. But we don't say like that. I read some books about we show of some people who can deal with big data or IT skills or something like that. So we can say that we need more STEM workers, I believe. But that is not much issue in Japanese society. People do not talk much about that. And our government are not much aware of that. But I believe there is a problem, and I read some books about that. So I can say there is a problem, but there is not much issue. It's not much issue yet in Japan.
All right.
Yeah.
Okay. Oh, there's one question, Prof. Could you share a bit more about the toy making or object building aspect of science lesson? Could you share a bit more about the toy making or object building aspect of science lesson?
Yeah, especially in the elementary level, a lot of activity like toy making. Yeah. In the grade 3, they using a rubber band to make a car. And in the activity, making the car is also the activity, but along the activity, they know something about how the rubber works. So yeah, and what else? They can make a wind car, and in the electricity topic, they make some kind of toys using a bulb and battery. There are lots of activities, toy making activity in science, especially in elementary level. I don't have a good picture at this moment, but maybe next time I can share with you.
Yeah, that's fine, Prof. So meaning that in elementary school, lots of activities
yes.
using toy making, yeah? Okay, all right. So for like USM students, they are going to secondary school for education students, and also we also have students from pure sciences as well. But I think the most important is when they start actually at elementary level, their exposure should be stronger or more, you know, before they go to the university level. So what would you advise the teachers, especially in probably kindergarten or elementary level? What what can they actually do to encourage, students to get involved in the STEM activity?
Yeah, in the elementary level, maybe more activity related to scientific inquiry. What is the problem, or what you want to find out from this activity, from experiment, and get the result? That is the cycle, right? Not only one cycle, but in a topic, teacher can prepare lots of cycles, lots of experiment, and get the idea following the inquiry cycle. So I think in elementary level, maybe the teacher giving as much as many chances to students. That is would be the important things, I think. In the lower level, like maybe grade 1 or 2, maybe they might not follow in the cycle, but they still teacher. I mean they still need some experience to manipulate or doing some activity, right? So maybe giving them more chance for them to practice, scientific practice. Yes, that is the idea. Yeah.
So more hands-on
For
activity
hazard,
for the younger children.
younger children, yeah.
Yeah, okay. All right. Maybe, is there any more question from the audience? Okay, if there is no question, thank you so much, Prof, for your input on sharing STEM skills based on Japan perspective and insights. So we learned a lot today, especially I'm very amazed because using simple activity, you can provide a very comprehensive explanation, looking at the combustion activity, and it's very interesting. So I hope that the students can apply when, they do the experiment with the students at school, and also try to integrate EDP before they conduct scientific inquiry investigation. Thank you so much, Prof. Hope to see you again next time. All right, so I'll pass to our MC.
Thank you very much. I just share the files in the chat box. I don't know if you can open it, but if possible, please check my presentation file. Thank you very much. Maybe the next time I can share my activity in face-to-face. Thank you very much.
All right. Thank you very much for the wonderful insights from Professor Toshinobu. That was a very marvelous sharing from you, and I hope everyone was able to gain much throughout the whole sharing. Now, ladies and gentlemen, we have come towards the end of the event. Once again, I would like to express our highest appreciation to Professor Toshinobu Hatanaka as the speaker of the day, and of course, express our gratitude to Dr. Nur Jahan Ahmad as the moderator. And to all participants, thank you for your active participation and for being cooperative throughout the whole webinar. With that, we would like to also sincerely apologize for any shortcomings from our side. For sure, we will continue to learn and improve for the upcoming events. Right, before we end the session, let us turn on our cameras to take a few photos to commemorate today's successful event. Open your cameras, everyone.
Di sana full screen view. Macam mana nak buat? Macam mana? Show satu.
Okay, is everyone ready? Is that all? Do open your cameras, everyone. We will give a few more minutes. Maybe some of you are still preparing. Okay. All right, now I will be taking the photos. All right. 1, 2, 3. Okay, another one. 1, 2, 3. Freestyle, another one. Oh, I've seen another participant open their cameras. Okay. 1, 2, 3. All right, marvelous. Thank you, everyone. Okay, thank you all. So, ladies and gentlemen, another gentle reminder for those who haven't registered your name for any MyCSDs, please do so because the committees has already sent the registration link in the chat box as well as in the YouTube commenting section as well. Okay. For USM students, you will receive MyCSD's points, and for USM staff, MyCD points. Also, please be informed that your eCert will be emailed to you in a few days' time. Thank you all for your patience. And once again, my name is Vanessa Indah Anak Pita. Thank you and have a great one.